Now we come to one of the most important concepts in enterprise generative AI, RAG, Retrieval-Augmented Generation. You may have heard engineers repeatedly talking about RAG, but why does a product manager need to understand it? Let's start with the problem. A large language model has learned from a large amount of information during training. But your company's private information is different. Your internal ServiceNow knowledge, your product documentation, your architecture documents, your policies, your project information, your JIRA tickets, your internal procedures. The AI model may not automatically know all of this information. And even if you provide information through a prompt, you may not want to send huge amounts of enterprise information every time. This is where RAG becomes useful. RAG essentially works like this. First, retrieve relevant information. Then, give that information to the AI model. Then, generate an answer based on that retrieved information. Think of it like an intelligent research assistant. Suppose you ask, what is our process for creating a high-priority SPM demand? A generic AI model may give you a generic answer, but a RAG-based enterprise assistant could search your approved internal documentation. It might retrieve the relevant process document. It might retrieve the demand guidelines. It might retrieve the product-specific rules. Then the AI generates an answer based on those sources. That's much more useful. Let's apply this to your ServiceNow environment. Imagine your organization has thousands of ServiceNow knowledge articles. You also have product documentation, SPM processes, JIRA guidelines, architecture documents, support documentation. Instead of expecting the LLM to memorize everything, we can build a system where relevant documents are retrieved at the time of the question. For example, what's the approval process for this type of demand? The system searches the relevant knowledge sources, it retrieves the appropriate content, the LLM uses that information to formulate the answer. This is the basic idea behind RAG. Now, let's understand the architecture at a high level. You have your enterprise data sources. These could include ServiceNow, JIRA, Confluence, SharePoint, knowledge bases, product documentation, and other approved repositories. That information is processed and indexed. Often, documents are broken into smaller chunks. Those chunks can be converted into numerical representations called embeddings. These embeddings allow a system to identify information that is semantically similar to the user's question. When the user asks a question, the system searches for the most relevant information. Then that information is provided to the LLM. The LLM generates the response. So conceptually, user, search retrieve, relevant enterprise data, LLM, response. This is different from simply asking ChatGPT a question. RAG gives the model context at runtime. And this is why RAG is particularly important for enterprise AI. Now, RAG does not automatically solve every problem. The quality of the answer depends heavily on the quality of the retrieved information. If the knowledge base contains outdated information, the AI may produce an outdated answer. If the retrieval system finds irrelevant documents, the response may also be poor. Therefore, product managers need to think about data quality, data freshness, access control, security, source reliability, and governance. This is extremely important. Suppose an employee asks an AI assistant about a confidential project. The AI should not retrieve information that the employee is not authorized to access. So enterprise RAG isn't simply a technical problem. It's also a product, security, and governance problem. This is where product managers need to work closely with engineering, security, and architecture teams. And RAG becomes even more interesting when combined with AI agents. Imagine an AI agent that can understand, I need to create a new network demand. The agent could retrieve the relevant product guidelines, check the required fields, understand the approval rules, create the demand in ServiceNow, then potentially create related engineering work in JIRA. Here we move from generative AI answering questions toward AI understanding context and executing business workflows.
That's a major reason why product managers should understand RAG. You don't need to become a machine learning engineer, but you should understand, what data does the AI need? Where does that data come from? How is it retrieved? Who is allowed to access it? How do we verify the answer? Those questions are critical when building enterprise AI products.
The fourth question is, what's a local LLM, and should a product manager even care? The answer is yes, you should understand it, but you don't necessarily need to become an expert in running one. Let's start with the basic concept. An LLM, or large language model, is an AI model capable of understanding and generating human language. Many popular AI services run their models in cloud environments. You send a request, the cloud service processes it, and you receive the response. A local LLM is different. The model runs within infrastructure controlled by your organization, or potentially on your own computer. This can provide greater control over data, privacy, security, infrastructure, and model behavior. Why does this matter to an enterprise product manager? Imagine your organization has highly sensitive information: internal architecture, customer information, proprietary product information, financial information, security information. You may not want all of that information sent to an external AI service. A local or privately hosted model can potentially reduce some of those concerns, depending on the architecture and security controls. But there are trade-offs. Running an LLM locally requires computing resources. Large models can require significant GPU memory. There are infrastructure costs. There are maintenance requirements. There are model update challenges. And the model may not perform as well as the latest commercial cloud models for certain tasks. So this becomes a product decision. Let's imagine you're building an internal AI assistant for an enterprise. You have three possible approaches. 1. Use a commercial cloud AI service. 2. Use a private cloud deployment. 3. Run an open source model within your controlled infrastructure. Which one is best? There is no universal answer. The product manager needs to understand the business requirements. What kind of data are we processing? How sensitive is it? How much traffic will the system receive? What level of accuracy is required? What latency do users expect? What is the cost? What regulatory requirements exist? What level of operational control do we need? These questions influence the architecture. Another important concept is open source or open weight models. Models such as Llama family models and other open models can potentially be deployed within controlled environments. But don't assume open source means free. There are infrastructure costs, engineering costs, security costs, monitoring costs, maintenance costs, and potentially licensing considerations. This is why product managers need to think about total cost of ownership. Now let's connect this to ServiceNow and enterprise automation. Imagine an organization wants an AI assistant that helps employees analyze internal SPM data. The assistant needs access to sensitive internal information. The organization may decide that certain AI workloads should remain within a controlled environment. A local or privately deployed model could become one option. But another possibility could be using a cloud model with strong enterprise security controls. The right decision depends on the organization's security and architecture policies. So don't make the mistake of thinking local LLM equals automatically better. That's not true. Similarly, Cloud LLM equals automatically unsafe. That's also not true. The decision should be based on security, privacy, performance, cost, scalability, governance, and business requirements. As a product manager, your job isn't necessarily to configure GPUs or optimize model weights. Your job is to ask the right questions. For example, what data will this model see? Where will that data be processed? Can the organization control access? How do we monitor the model? What happens when the model needs to be updated? What is the cost per user? What happens when usage increases 10 times? Those are product management questions. And this is why understanding local LLMs is valuable. You don't need to become an AI infrastructure engineer, but you need enough knowledge to participate confidently in architecture discussions. Because increasingly,
product managers will be involved in deciding how AI capabilities are delivered, not simply what features the product should have.
Should remain within a controlled environment. A local or privately deployed model could become one option. But another possibility could be using a cloud model with strong enterprise security controls. The right decision depends on the organization's security and architecture policies. So don't make the mistake of thinking local LLM equals automatically better. That's not true. Similarly, Cloud LLM equals automatically unsafe. That's also not true. The decision should be based on security, privacy, performance, cost, scalability, governance, and business requirements. As a product manager, your job isn't necessarily to configure GPUs or optimize model weights. Your job is to ask the right questions. For example, what data will this model see? Where will that data be processed? Can the organization control access? How do we monitor the model? What happens when the model needs to be updated? What is the cost per user? What happens when usage increases 10 times? Those are product management questions. And this is why understanding local LLMs is valuable. You don't need to become an AI infrastructure engineer, but you need enough knowledge to participate confidently in architecture discussions. Because increasingly, product managers will be involved in deciding how AI capabilities are delivered, not simply what features the product should have. In our next video, let's explore responsible AI and what every product manager needs to know. Stay connected, stay curious, and happy learning.